All right, ladies and gentlemen, welcome back. Professor Connect here, bringing you guys another video, this time with my second part to naming chemical compounds. This one's going to be over type 3 compounds as well as what are called polyatomics. So before I get started, I do want to address a couple things. Type 3 specifically, type 3 will involve naming specifically two nonmetals that are bonded together. So these are going to be specifically two nonmetals that are bonded together. So this could be anything like oxygen and hydrogen. This could be oxygen and fluorine. This could be nitrogen and sulfur. As long as they're two nonmetals, then that actually fits our criteria. Polyatomics are actually a special kind of placement inside of the periodic table and inside of chemistry in general. I shouldn't say inside the periodic table, but polyatomics are actually a special type of molecule that are when a group of atoms act as a single unit. So for example, you may have seen something like this before where you see CO3, and sometimes you might even see its charge on there, CO3 2-. This is actually an example of a polyatomic ion. This is known as carbonate. And basically, if you see a group of atoms all bundled together and they have a charge, then that actually means that they're acting as a single unit. It is treated the same as if you have a singular atom in most cases, at least at the basic level. And so polyatomics usually all act similar. Another really basic example for you guys that we have more than one to go off of is NH4+, which is typically the only positive polyatomic ion that is ever worked with. And this is known as ammonium. Ammonium. There we go. Ammonium, which is a positive polyatomic ion. Most polyatomic ions are negative in nature, and most of them actually contain O in them. So you might actually hear the term from a teacher, a polyatomic oxyanion, and that's actually because oxy stands for oxygen, anion tells you that's negative. And so they're actually giving a specific type of polyatomic. But really, a polyatomic is anything that can act as a group. Sometimes inside of problems, they'll even be placed inside of a parenthesis with something in front of it. Like maybe you'll have element, let's say X in front, and then you'll have a polyatomic. Let's say we have that CO3, and they won't usually list the charge, but then you know that this is bonded to the carbonate. Sometimes they actually won't leave that at all, and they'll just say XCO3, and you are just to assume, in most cases, that that is actually treated as a polyatomic. So that actually gives us our two really basic overviews of what those two types are. Now I'm going to go through a couple different examples and kind of tell you guys how to do this. So for type 3 naming specifically, type 3 naming is actually where we use our prefixes. So type 3 naming is going to involve all of our prefixes, such as if I have one of something, I will say mono. Mono means one, and I'm going to go through these real quick. So mono, di means 2, tri means 3. This is the one that always catches students off guard. Tetra is 4, and then the rest of these are actually pretty straightforward for the most part, even here in America. Penta is 5, hexa is 6, hepta is 7, octa is 8, nona is 9, and deca is 10. So those are typically going to be the ones that at least I make students work with. Most of the time I don't ever go past 10. Some teachers might, but that gives you guys a little bit of a heads up. When it comes to type 3 naming, typically if your first element is singular, you don't need a prefix. Notice I said you don't need a prefix. Some teachers, again, they might actually request that you give one. That way they get you used to the idea, because it never hurts to say mono in front of something. It may not always be necessary, but it doesn't hurt anything. It actually means the same exact thing. So anyway, let's go through a couple different examples. So real quickly, I have my N3O4. I'm gonna have another example of ClF3. I'm going to have a third example of CaOH2. Ooh, that's actually not a type 3. I shouldn't use that one. That's a polyatomic right now. Whoops, wrong example. There we go. We'll do Actually, I'll do a funny one for you guys. H2O. And then we'll do HCl. So I kind of did a couple different examples, and I actually did HCl on purpose because if you get further along in chemistry, you're going to learn an acid name for this. So anyway, if I name this, I first of all look and see, is it type 3? So I have a nonmetal and a nonmetal. That means it is type 3. Then I input my prefixes for each. I have 3 of these, so I'm going to say trinitrogen. So the first element will always keep its original name. And then this is going to be tetroxide. This is my one that actually breaks my rules. I don't have to say tetraoxide. That's just kind of a mouthful. So instead, usually it gets shortened to tetroxide. You can say tetraoxide. I don't count my students wrong for this. Again, this is an O right here, so N3O4. But I say trinitrogen tetroxide. That is completely fine. For this guy, again, I'm gonna look at this first. So I have chlorine trifluoride. That was a mouthful. Chlorine trifluoride. So again, I only changed the IDE ending on the first one. This one's actually kind of fun. This one, H2O, you guys are gonna know that as water. Sometimes you'll hear it called dihydrogen monoxide. And dihydrogen monoxide is the big fancy name for water. Now, HCl is going to be hydrogen. And here's where things get kind of weird, because really true naming convention would say monochloride. This would be if you were following type 3 naming convention, you'd say hydrogen monochloride. This actually, because it's an acid, gets other names as well. But for now, I'm gonna say this is actually a name that is acceptable, it is common, so you could actually use this name. So, until you have a teacher who says, no, name it as an acid, and then once they tell you that, do so. So that gives you a couple different examples. Again, remember, this number will tell you how many of each you need, and then you pair that with the IDE ending where needed. So the second element will always follow the IDE ending, just as all of our other examples. Let's do a couple polyatomics. So I'm gonna pick out a couple. Usually if you have a teacher who does polyatomics, they will usually either give you a table of polyatomics, or you might have an unlucky time and you might have to just memorize some of these. It kind of depends on your teacher. I usually personally don't make students memorize polyatomics because, in all honesty, I'd rather them understand application, but there's no harm in learning them. It sometimes just makes solving problems faster. So notice I now have the parentheses with the subscript next to it, which means I now have 2 of those object. And whether or not you see the parenthesis or not, you have to look out for these polyatomics. So first of all, let me just kind of give you a brief overview. NO3 is a polyatomic, NO2 is a polyatomic, OH is actually a polyatomic, and CN is a polyatomic. That way I kind of like show you those first. Now, when I name polyatomics, it's actually super easy. I actually typically just name it like type 1. So I say sodium, and then I just actually name what the polyatomic is in most cases, because almost all these polyatomics are negative. So I always name my positive piece first, so sodium. And then I find NO3 on a table of polyatomic ions, and this guy's name is nitrate. I don't need to change anything about it. I just follow the cation, and then the polyatomic anion name just stays normal. This guy, it doesn't matter that there's 2 of them, because you usually will just assume that charges will cancel. So we say calcium, and notice NO2 is gonna be different than NO3. That's actually why I picked these guys. Nitrite. So this is actually gonna be a very, very tricky thing for some people, because you're gonna wanna jump to nitrate quite a bit, and you're gonna have nitrite. So what you're gonna notice on these polyatomic ions is they are gonna be families among them where they have similar naming conventions, because it's just different by 1 oxygen. This guy, OH. Once you get to a class like organic chemistry, you learn that this is actually an alcohol group, but this is calcium. Oh, let me think. That should be calcium hydroxide. If I recall correctly, hydroxide would be the name for the OH group. And this guy over here will be lithium cyanide. So the CN group is the cyanide group. So there we go. That gives you guys a brief overview over type 3 and polyatomic naming. I want to make sure I kind of cover both in one video, because now between these two videos, that should cover, I would say, about 85% of naming that you have to go through at high school Chem 1 level, unless you have a teacher who wants to go over something really specific, like maybe acid names. So with that being said, this gives you guys a really good overview between this video and the last one of naming chemical compounds. So if you guys have any questions, leave them down in the comments below. I hope you guys enjoyed the video. If you did, make sure that you share it with a friend or leave a like or subscribe. And I hope to see you guys in the next video.